Hello, Year 10. So here is what we're going to be learning today. We're going to continue solving equations, but this time we're going to take a look at when there's variables on both sides of the equation. I'm going to do this one first, just to remind you how it's done. So step one, we always want to try and see if we can eliminate one of the terms that has the variable in it. In this case, I'm noticing there's 9x's on this side and 3 on this side. So first thing I'm going to do is take away 3x from both sides. I'm left with 6x minus 20, equals 22. Next, I'm noticing that x is being multiplied by 6 and then 20 is being taken from it. So the inverse for that would be to add 20 to both sides. I'm now left with 6x equals 42. Last step, I divide both sides by 6 to get a solution of x equals 7. Please make sure throughout this video that you're pausing whenever you need to in order to write things down or to interpret more. What I want you to do is pause the video and continue to try to do this one on your own. Let's see how we did. So hopefully the first thing you did is you subtracted 4x from both sides to get 3x minus 22 equals 13. Next, add 22 to both sides. 3x equals 35. When you went to divide by 3, hopefully you noticed that 35 is not a multiple of 3. You might have panicked. It's okay, don't worry. That is actually correct. So you can leave your final solution as 35 over 3. If it says in the instructions to make sure you write as a mixed number, please do so. This just says solve, so you're okay to leave it like that. Here are the ones we're going to be taking a look at today. So again, there's x's on both sides of this one, but in this case, I've been given a fraction. So in a first instance, if you ever have a fraction, you need to make sure, because we want to isolate this 5x term in the numerator, so we're going to multiply both sides by 3. Now I've isolated the numerator, so the left-hand side of the equation reads 5x plus 3. Don't forget you must multiply every single term by 3 to get 15x minus 27. And now it becomes a very similar equation to the one I've just done. So I will subtract 5x to both sides. I now have 10x minus 27. I can now add 27 to both sides. 10x now equals 30 to get a solution of 3 for a final answer. Don't forget, please, again, pause wherever you need to. Next one you're going to try is, can you please do this one? Let's take a look and see how we did. First thing hopefully you did is multiplied both sides by 2. Again, multiplying everything on the right-hand side by 2 every single term. So you would get 3x plus 7 equals 62 minus 8x. Now I'm noticing there's a negative x term here, and I like to work with positives because I find them easier to work with, so I'm actually going to add 8x to both sides. If you subtracted 3x from both sides, you should still get the correct same answer as long as the rest of your steps are fine. 11x plus 7 equals 62. Next, I would subtract 7 to both sides to get 11 equals x. Don't forget the x. 7, let's see, carry 12. So what would that be? 55, which gives us a final solution of x equals 5. Perfect. All right, last one. What happens if the x terms are in your denominator? Now, don't forget, like we did last time, you have to isolate so you can get rid of your fractions. What I mean by that is we need to be able to, again, manipulate the equation like we did here to just get an equation that has one line in it, no more fractions, makes your life a little bit easier. So in this case, what I want to do is I actually want to multiply both sides by each other. What I mean by that is, if you ever have two fractions that are equal, you can actually cross multiply in order to create a different equation. So in this case, what I mean by that is I would do 2 times 4x equals 3 times 3x plus 17. If you expand that out, you get 8x equals 9x plus 17 times 3, 351. All right, keep going. So minus 8x from both sides. Notice this has nothing left, so I'm going to put in 0 there. And final solution would be x equals negative 51. Again, whenever you're given an equation and you have two fractions that equal to each other, don't forget you can cross multiply and then expand everything out in order to create an equivalent equation. Last one, can you please attempt to solve this one? And then for this solution, can you please fill out the question on Firefly with which answer choice you think is correct?